Hello, I'm Anastasia Kisil. I'm from University of Cambridge.
I'm Ian Thompson from the University of Liverpool.
I'm Gennady Mishuris. I'm Professor of Applied Maths in the Aberystwyth University.
So the theme of the program is on Wiener-Hopf technique. It's a very well-established technique. It's been over 90, well, just under 90 years. And interestingly, we have one participant who is 91. So he was alive when the Wiener-Hopf technique was first introduced. And what's exciting is that in those 90 years, it's developed in all sorts of different directions. It's being developed and more applied. So this is, in some sense, where the technique was born. It was born out of applications. But in another sense, we saw loads of interesting examples how pure mathematics has picked it up and developed those ideas. We had people from all sorts of communities come together, and it's been great.
Yes, it's true. And actually, we tried to organize the workshop on the second week, and this workshop consisted mostly from, let's say, 3 parts. The first part was mainly pure theoretical part devoted to this method. The last was the application part, and in intermediate we have distinguished lectures from the people from United States, our senior colleague from Israel, Professor Slepian, who was exactly born together with the technique.
Yeah.
And what is interesting that actually the technique, I think nowadays starts to have the second spell because of the development in the matrix factorization. So it's
Yes, there's still many unsolved problems that can be written as Wiener-Hopf equations, but those equations cannot then be solved. There's much still to do, and I think there's been some great lectures on new approximate methods for solving these problems from people in all sorts of different physical disciplines.
And what is also interesting about this program, probably Anastasia would like to tell a few words about this. We have also the summer school.
Yeah, so we had a very intensive 2 weeks where we just listened to all sorts of interesting ideas, and then we had 2 weeks of talking to each other about various ideas. So the month has gone past quite quickly, I think.
Yes.
But as a result, we have a much better understanding of, well, I think we've achieved the bringing together of different communities 90 years on from the start of the story.
The Wiener-Hopf method has applications in many areas of physics, particularly where a wave that could be a sound wave or an electromagnetic wave strikes a body with a sharp edge. Often there's no other way, or at least no other way known, to analyse what will happen. And the Wiener-Hopf technique can provide tremendous physical insight into these problems.
Yeah, but I think more recently what's very interesting, what emerged, is the idea that we can not only solve the standard mixed boundary value problems, but also free surface boundary value problems is a very interesting application of Wiener-Hopf technique. And of course there's crystal growth, there's fracture mechanics, there's all sorts of new materials that we want to analyze, and there's new problems rolling out from glaciology and all sorts coming our way. So it's there's more problems than we can solve, which is a good thing.
Yes, absolutely. Also, if you think it's also problems from area of healthcare, from financial mathematics and all other problems. Actually, we had a short discussion how we can make the difference applying with this community to some grants directed to the challenges, and we were so surprised writing everything on the desk what we can make the difference to, and it was very exciting. But now we need only simply follow and build on this what we achieved here.
I think we have people which have come from the engineering department, from the physics department, from maths department. They all seem to have interacted very well. I can tell you kind of a few anecdotes that we have one participant who's just starting his PhD. He was thinking of doing a PhD in some other area. He came to the workshop, now he's convinced that Wiener-Hopf is the way to go. So that's one of success stories. Another guy who's recently learned about the Wiener-Hopf technique went back to his university, talked to his old friend who's doing stochastics about this workshop he's been at, and she said back to him, well, actually I do Wiener-Hopf as well. So we kind of learning that other people we might have known for a long time also do very similar stuff. So I think we had a massive range of people from various countries, various disciplines, various age groups, as we mentioned, all the way from PhD students to very established professors. So, and I've been walking around and looking at who's been talking to who as an organizer, and it's been nice to see that not only an established people that have known each other are working on problems together, but also some people that I know haven't interacted before have started to kind of putting pen and paper together and exchanging ideas. So.
And we've gathered a list of unsolved problems from different disciplines, from electromagnetism, acoustics, fracture mechanics, and we hope to see some development using some of the ideas from the workshop for those problems.
I would also add something. So the main topic is Wiener-Hopf, but Wiener-Hopf is really such a general technique, can be used in different areas, and in these different areas there are other methods what people using who are not really familiar with Wiener-Hopf. We have few speakers coming to us telling about those problems too, even they are not really specialists in Wiener-Hopf. We wanted to understand and to give them first some new ideas from our area, simultaneously to understand whether something that is very similar to attractive to start immediately with the Wiener-Hopf, as we are specialists in the area. Maybe something has been done with different techniques which would help us to understand how to better use our technique in this particular case. So it was really not only between the disciplines, it's also between the people working in different methods too, working even in the same discipline.
I mean, I did a quick search on the number of papers which use Wiener-Hopf in MathSciNet and the Web of Science, and it was around 5,000 on there, and in the last few years there were at least 500 or so, and that's from a massive range of disciplines. So it's a topic of current research, and there's a lot of potential in it.
So we hope to meet each other in a year or 2 years' time, and really to see the development and see how much we would be able to do, and also in terms of impact, as I just mentioned previously, with all these challenges, now all the funding bodies requested for us not only develop one particular method, but simply to use it efficiently for the societal challenges, technological challenges, and all other challenges. So we will try to enrich our collaboration even further to make the difference.